So this is going to be a refresher lesson. This is chapter 1, lesson 1, so we're moving back to chapter 1, and this is going to be over solving simple equations. So the most important thing to remember is the golden rule, which says that whatever you do to one side, you must do to the other side. So we'll get into that a little bit more, so just remember that golden rule. And then here's our 4 rules to solving algebraic equations. So the first thing that we're going to do is separate the equation at the equal sign. If it is an equation, that means that you're going to have 2 numbers that are set equal to each other. So we could have like 2 plus 3 equals 1 plus 4. If we simplified both sides of this equation, we would get 5 equals 5. An equation has that equal sign. I'm saying that one side equals the other. An expression would just be one side or the other. So for an example, this is 2 plus 3. That is an expression. 1 plus 4, that is an expression. So the technical definition of an equation are 2 expressions that are equal to each other. So we have 2 different expressions that are set equal to each other. So we draw a line at our equal side because then we have 2 sides of our equation, 2 expressions. And then whatever you do to one side, you have to do to the other side. And that's what I mean by that golden rule. Step number 2 is combine like terms on both sides. That's kind of what we did here. I know that 2 and 3 are like terms, so I combined them. 2 plus 3 gave me 5. What's happening with addition subtraction? Do the opposite. What's happening with multiplication or division? And you're going to do the opposite. And that's to both sides. So let's move on to some problems. So this is what I mean by the operation in the inverse. So this is what I mean by do the opposite. So inverse means opposite. So the opposite of addition or the inverse of addition is subtraction. And this would be an example equation. So I see that there's addition there. To undo this or use the inverse, I'm going to subtract it. Because when I have a plus 3 there, I know if I took away 3, that would equal 0. X plus 0 is just going to be x, so that goes away. But whatever you do to one side, you have to do to the other. So since we took away 3 on the left, we have to take away 3 on the right. And so I would get x equals 1 for that first problem. The opposite of subtraction or the inverse of subtraction is addition. Multiplication and division are inverses of each other. And this is going to be your new section over here. So the opposite of a square root is a square. The opposite of a square is a square root. So since I see a square root right here, I know to undo that square root, I'm going to have to square it. If I square it, I just mean put it to the exponent of 2, so it becomes a power. When you do that, since they're inverses, they cancel each other out, just like how we solved up here with this addition subtraction problem. And so that goes away, and we're left with just our x. And then we solve 4 to the second, which I know means 4 times 4. 4 times 4 gives me a 16. So I know that x equals 16. And then down here, the opposite of a squared is a square root. So since this x is squared, I have to square root it to get that to go away. But whatever I do to one side of the equation, I have to do to the other side of the equation. So that means that I have to square root 4. When I take the square root of 4, it means what number times what number equals 4. And I know that 2 times 2 equals 4. So since that goes away, we're left with just x on the left. And I know the square root of 4 is going to be 2. And so that would be my answer for that problem there. I'm going to try some of these examples with you, and then I'm going to leave the rest for you to solve. So if we're looking at this first problem here, I see x minus 12 equals a negative 22. Since it is a subtraction problem, I know that I'm going to have to use addition because addition is going to be its inverse. So the first thing that I'm always going to do is draw a line at the equal sign to separate my left and my right side. I'm looking at the side with my variable. So my variable in this case is h, and I know that this is a subtraction problem, so I'm going to have to be doing addition. I'm going to add 12 because if I had a negative 12 plus 12, that equals 0. H plus 0 gives me just h left over, which is what I want. My goal at the end of these is to get the variable equals some number. Now I don't just drag down my negative 22 because I have to remember that golden rule. Whatever I do to one side of the equation, I have to do it to the other. So right now I've got negative 22 plus 12. When I add those two numbers together, I know that I'm going to be getting a negative 10. And so my final answer is h equals negative 10. I can double check myself because I know that h and negative 10 are the same thing. They're equal to each other, which means instead of writing an h down, I can write a negative 10 minus 12 equals a negative 22. I'm going to KCO that, and then I get negative 10 plus negative 12. When I add those two together, since they have the same sign, I'm just adding those numbers. So 10 plus 12 equals 22, and then I'm keeping the sign. Now that I've simplified that side, I'm going to bring this down. So I've got negative 22 equals negative 22. Since it's the same exact thing on both sides, I know that I did it correctly because negative 22 does equal negative 22. Let's say that you went through all this and you got 2 equals negative 22 instead. You have to ask yourself, does 2 equal negative 22? And your answer should be no, it does not. If you get that as your check, you know that you did something wrong over here. So go back to solving the problem and retry it. Make sure that you check your steps. Maybe instead of adding a 12, you subtracted 12 from both sides. So go back and double check yourself if this happens when you go to check. Now I am going to do number 3 with you. So with number 3, the first thing that I'm looking at is this left side of the equation because it has our variable g. I would say this side by saying g divided by 12. Since it's a division problem, I know the opposite of division is multiplication. So if I multiply by 12, that's going to cross that out because that simplifies to a 1, and anything divided by 1 is itself. And so that means that we're going to be left with a g. But whatever I do to one side of the equation, I have to do to the other. So since I multiplied by 12 on the left, I have to multiply by 12 on the right. I know that 2 times 12 is going to give me a 24. So my final answer is going to be g equals 24. Now I still have to go back and double check myself. I know that those two are the same thing. So instead of writing a g, I can write a 24 in my numerator. Divided by 12 equals 2. I know that 24 divided by 12 equals 2, and so I get that 2 equals 2. Since the left side does equal the right side, I know that I'm right. The last one that I'm going to do with you is I'll do number 5. So I can see that the variable is on this left side, so that's the side I'm working with, and I see a square root. The opposite of a square root is squaring it. So I'm going to take it to the second power. That crosses that out and leaves me with just an x. Whatever I do to the left side, I have to do to the right side, so that means that I have to square that 5 as well. I know that 5 squared means 5 times 5, which is going to be 25. And that's my answer. I'm going to double check it. When I do this, I'm taking the square root of 25 because I'm replacing that x or substituting that x with my 25. I know the square root of 25 means what number times what number equals 25. Well, 5 times 5 equals 25, so I know that my final answer is going to be 5. Since the left side equals the right side, I know that I did that correctly because 5 equals 5. Now you have problems 2, 4, 6, and 7 to solve on your own. If you pause the video, I'm going to clear this out. So you're doing 4, 6, 7, and 2 on that side. You're doing those 4 problems. Pause the video now, and I'll give you your answers in a second. And here are your answers. So for number 2, you should have gotten k equals -5, 4, v equals 7, 6, x equals 6, and 7, p equals 16. So this one was a little bit harder because you had to simplify this first. But I know that 1/2 of 6 is 3, because half of 6 is 3. And then since it's a subtraction problem, I'm adding on both sides. 13 plus 3 is going to give me my 16 there. If you've got any questions over any of these examples, please pause the video now and send me an email. Next, we're going to be finding the missing angle. So I know from the angle sum theorem, which means that we're adding up all the angles. So we know that the word sum means addition. So it's literally addition of the angles. We're adding all the angles together. For a triangle, the sum of the angles is 180 degrees. So we have 2 of these angles. We're just missing this angle right here. So I know that if I add up all of those angles, so we've got 27 plus 82 plus, we don't have this, so I'm just going to write an x. Because a variable is used in place of a number if we don't know what that number is yet. And I know when we add up all 3 of those numbers, we're going to get to an angle of 180. So now I'm going to draw my line. I have to simplify this left side first. So I'm taking 27 plus 82, and that gives me 109. We've still got our x. We can't combine those two because they are not like terms. And then we still have our equals 80 on that side, or 180. From there, I see addition. This is a positive number. So the opposite of a positive number is going to be a negative number. So I know that we're going to be subtracting those. So I always just want to get down to 0. So since this is positive, the way that I do that is subtracting 109. But whatever I do to one side, I have to do it to the other side. And so on that left side, I'm left with an x. And then on that right side, I'm taking 180 minus 109, which is going to give me a 71. So I know that my angle x is equal to 71. We could also write it as angle t because there's that t there, equals 71. 71, there we go. And then we use our degrees symbol. You can always double check yourself by adding together 27, 82, and 71 to get your final answer. I want you to pause the video and try the second problem on your own, and I'll give you the answer at the end. The only thing to remember is the sum of the angles for a pentagon is going to be 540. So rather than it saying equals 180 like it did with the triangle, it's going to say equals 540. But you're still adding together all of those angles because it's still the sum of the angle measurements. So pause the video now and try that problem. And here's your answer with some work. So what I did to get this 377 number is I added up all four of those angles. So when you add up all four of those angles, you should get 377. Subtract that on both sides because that cancels each other out and gets you to 0 plus x, which just equals x. Subtract that, and then you get the actual angle that you're looking for. So you should have gotten x equals 163 degrees. Now it's time for you to try these homework problems. So you're flipping to page 7 and 8 in your textbook and answering these questions. If you have any problems, please just send me an email.